Me, sir.
That I am covered all lecture. I have covered all the video lectures.
Okay, so you got the concepts behind all the topics and all. What is independence rule, what multiplication rule, and Bayes theorem, everything.
Yes, sir.
Okay.
Concept-wise,
Yes, sir. But application needs some practice.
application-wise is something which is
Yeah,
Application is bit tedious.
yeah, I agree. Just do practice. I can just say this.
Sir,
So
can I say something?
yeah, yes, please.
I have tried the tree method for finding the probability, and I
Mhm.
find it easier and accurate as well. But in some situation, I got it wrong. I don't know what I am doing wrong. So can you explain a tree method or something? Is it viable to do that, or just stick to the same method which you have taught?
No. It's not strict to similar. You can try Venn diagram. You can try through the tree diagram, and you can try to see if you got the concept correctly. Then you can try it by direct formula and all things. So it depends on the individuals actually. Tree diagram actually no, it's very good. Uh, but it's involved. So suppose you have a lot of cases, then it took a lot of timing actually. So, but if you are, I mean, if you are perfect
Comfortable,
in
sir. I am
paper,
comfortable in tree method, but some questions are not like happening. I don't know why. We can discuss
okay.
after this session.
Yeah, we will discuss this. Okay, so there are 19, 18 participants should be there. So the people who have not joined this PRDX slides, kindly enter uh, browser on your browser or joinpt.com. After that, kindly enter this code HZIBSA. Okay.
Sir, please discuss some problems, similar type of graded assignment, because I have faced lots of problem to solve the graded assignment. And my
Okay, we'll discuss.
base theorem concept is not clear. I have watched the video, but it's not clear to me.
Mhm. Actually, took some, I mean, demands some practice. See, in base theorem, you should identify the what are the events given to you, like individual. I mean, individual events means probability of A, B, and C, whatever, and what is it A given B or B given A or C given A. So all of the things actually you have to identify. Means you have to focus on the statement of the question. What is the given in the question? Okay, we'll discuss. There is a question in this slides related to Bayes theorems and conditional property, and all. We will discuss. No worry about it.
Okay.
Okay, so there are 24 participants, except two. I think there should be 22 who have joined this. People who have not joined it, kindly join this entering on your joinpd.com, and then you have to enter this code HZIBSA. After that, we will start the session. Please join it fast. Okay, nice. There are 18 students. Let's wait for 1 more minute. After that, we will start the class.
So the quantities of MCQs are is also very less in this week probability. I think due to the concept rigidness, numerical
Yes.
ability questions are very more like very much. MCQs are at 25%. I think less than 25% are MCQ and all are numerical ability type.
Actually, that some you can say for checking accuracy. If you have option, then you can guess that it can be can
Yeah, that
it could
I
be
am
option.
going wrong or I am going
So,
correct.
yes, yes. Right. Okay, there are 9. Okay, let's
Sir,
start the
your voice is breaking,
class.
not clear. I don't.
Now, is it for everyone or now is it okay?
A
It
little
was for
bit choppy,
everyone,
sir. A little bit choppy, sir. Due to network
and
issue.
it was for everyone.
Yeah.
Sir,
Okay.
today there is back-to-back 3 sessions. That's why I thought that participants are less.
Back to back
Ah,
today.
4
Okay.
to 6, 6 to 8, and 8
Yes,
to
sir.
10.
4 to 6, 6 to
Okay.
8, 8 to 10, and on
Uh,
demand is also there 10 to 11. Today,
For
all four
CT.
subjects.
Okay.
and
Yeah.
also,
Okay.
and
All
also
four
there is a
subjects.
extra seminar type of session is
Session,
there
yeah.
with AIML from 5 p.m.
Okay.
That's why
Oh.
maybe the participant can choose.
Yeah, yeah, might.
But
Yeah, that's it. Okay, okay. That's start. Okay.
you
So
can
this is
start.
the system. Yeah, yeah. This is the system for. I mean, this is all with the system for week 8. Okay. So please keep pen and paper ready with you so that you can solve the questions. And you are familiar how to answer the question. Yeah, below you can enter your answer. Okay. So yeah, this is the first question. I think 2 to 3 minutes will be more than enough. Yeah, one more thing. In the last system, you have remembered we were discussing that question, the replacement, drawing the ball. How many of have remembered that one?
Yes, sir. Me.
Okay, so that was I mean with replacement, I think it was 4 red balls something. So with replacement, it will be 4/12 into in the second draw. It will be again 4/12 because we are doing the
Yeah,
with
yeah.
replacement.
And
Okay.
without it, it's gonna be 4
Yeah,
upon
it will
11.
be 3
Yeah.
by 11.
3. Yeah, 3 by 11. Yeah.
Yeah, that was the okay. Okay, now I think 2 to 3 minutes will be more than enough. Okay, so please solve it and enter your answer up to 2 decimal accuracy. Okay, and people who have not joined the peer day till now, kindly enter joinpd.com on your browser, and after that you have to enter this top right corner code HZIBSA, and you will see this slide. There are I mean there should be 34 responses in this slides. So rest of the people who have not joined, kindly join this. I hope you are familiar with how to join.
Sir, can you share the link for that in the chat or somewhere?
Link for what?
This
Joining the slide.
Yeah.
Yeah, see, just enter this joinpd.com. Okay. Yeah, Siva has entered. Yeah, enter on your browser joinpd.com. After that, you have to enter the code HZIBSA. Okay.
Done, sir.
Okay, let's wait for 1 more minute. There are only 5 participants who are left. I think this is very easy one, right?
Yes, sir.
Sir, 8 by 13.
Okay, we will see what is the answer. Okay, let me see the responses. 0.62, 0.61, 62, 61.07. I can see 0.36 also, 615, 61. Okay, majority is 6.62. Okay, let's see the solution for this one. The answer is just 8 by 13 because we have to choose the probability of we have to find the probability of red ball, and in that there are 5 blue balls and 8 red balls. So what is the total number of case? 30. And what is the favorable case for the number of red ball is 8. So it's nothing but 8 by 13, which will be 0.62. Right? It's clear?
Yes, sir.
Okay. Is it clear for everyone?
Yes, sir.
Yes, sir.
Okay. So we can move for the next slide. Yeah, this is the question one. I mean, that was prelude one for this question. This is the, I mean, you have to use the concept of previous one in this question. Okay, I think 3 to 4 minutes will be more than enough for this question. So please solve and enter your answer up to 2 decimal places. Uh, People who have not joined this peer deck till now, kindly enter joinpd.com on your browser. After that, you have to enter this top right corner code, this HZIBS, and then you will see this slide where we have. So kindly join this so that we can solve the questions together. Okay, there are 25 responses. Let's wait for a couple of seconds. After that, we will see your responses and solution as well. Okay, I think we can move for the, let me see, responses from your side. 0.2526, okay, 2651, 0.26, 0.26. Someone has entered 1.03. I don't know how probability cannot exceed 1. First of all. Okay, so yeah. So any one of you would like to tell what will be the correct, correct answer for this one?
8 by 13 into
0.
8 by 13 into 5 by 12. 8 by 13 is the first probability of getting a red ball. The second one is 5 by 12. So 8 by 13 into 5 by 12.
Yes, that is the correct answer. And here we have applied actually multiplication rule. Okay, means first event is what? First ball is a red and
Sir.
B is the second. Yes.
Sir, I do the same, but made a plus 8 by 13 plus 5 by 12.
No,
That's
why
why-
plus? See, why plus? What is the question? Your question is you have to find the probability that the first ball is red and the second ball is blue, right? It is asking about and let one second. Okay, so what is your first event?
one red ball.
Ball is red, right?
8 by 13.
Okay, and what is the second event? Ball is the blue, right?
Without
What is your question?
That's why 5 by 12.
Okay, it's a without repetition. So what is your question? You have to find the probability that red and blue, right? You have to find red and blue. That means I can find the probability of red ball into probability of blue ball given red ball. See, this given means what? Means, see,
First ball is red.
first ball is red. So first ball is red. So what is the probability of drawing of first ball as a red? It's 8 by 30 into what will the probability of drawing a blue ball? 5 by 12. That's it.
Sometimes when I problem related to choose the shirt pen from a shop, I made plus. I don't know.
No. See, what is this? See, we focus on this one.
Okay.
Right? It's not about what is the probability for drawing a red ball or drawing a blue ball.
And means always
Yeah.
multiplication.
Yeah. Okay. Yeah, one second.
Okay. Okay, sir.
Sir, I have a question too. Sir, can you hear me?
Yes, please. Yeah, I can.
So basically, for this question, they ask like first ball should be red and the second ball should be blue. Let us say if they asked first ball is blue and second ball is red, we'll still get the same answer, right?
Yeah, you will get the same answer. You see, if first ball is the blue, then what will be this one? What will be this one?
So
red
we'll
and blue.
just do.
So I can write
5 by 13 into 8 by 12.
Probability of red given blue, right? I can write this one or not?
Yes, sir.
Okay. So for finding the probability of blue, what will be this? 5 by
13 into 8 by 12.
and for probability of 8 by 12, this is the same.
Yes,
Suppose
sir.
question is like first ball is the red and second ball is the red. Then what will be the answer?
I think we would go 8 by 13 into 7 by 12. Is that
7
correct?
by
8
12.
by 8 by 13 into
7 by 12.
Yeah.
okay. Okay, that
So I
is
have a
for
question.
without
I have a follow-up question, sir, actually.
yes.
Let us say instead of drawing them in order, we were to draw them both at the same time. And we wanted the probability that one ball should be red and one ball should be blue.
Okay.
How would we proceed for that one?
For what? See,
Like
here
drawing both the balls simultaneously rather than one after the other. If you take two balls simultaneously,
yeah, sorry. Yeah, please. Please.
yes, sir. So my question was, if the question was like, if two balls are drawn simultaneously at random, what's the probability that one of them is red and another is blue? How should we do that one?
Okay, and this is not simultaneous.
Yes. I understand, sir. It's not this question, but related to this one.
No, I'm asking, this is simultaneous or not?
I mean, here we are doing them one after the other, right? So I would think it's not simultaneous.
So should it be 8C2 divided by 13C2?
If we're doing 8C2, that would be like assuming both the balls are red, right?
Yeah,
But we wanted like one red ball and one blue ball.
Okay, one red ball and one blue ball.
Okay.
So it would be
Okay,
8C2 into 5C, sorry, 8C1 into 5C1 divided by 13C2.
8C1 by 13C1.
8C1 into 5.
Is that the correct answer? I mean, I'm not sure. That's why I'm asking. I don't know myself.
No.
Hello,
Is
sir.
that the correct answer, sir?
Actually, see. I want to know your opinions actually.
Sir, my
What do you
opinion
think?
Sir, my
Yes.
opinion is 8C1 by 13C1 into 5C1 by 12C1.
No, you are doing 8C1 by 13C1, right? Into 5C1 by 12C1. So it is same as 8 by 13 into 5 by 12.
Okay.
Okay.
Yes.
Okay. So anyone would like to answer this question?
Yeah, actually the approach that I have taken, I've selected one red ball out of 8 red balls that we have, and then I have selected one blue ball out of 5 blue balls that I have at the same time, and I'm selecting this from 13 red and blue balls. From a total of 13 red and blue balls, I'm selecting 2 balls from the total of 13 red and blue balls. So that's why I used the product of these two, and I divided this by the total probability.
Okay. If you solve this quantity, what we will get? 8 by 13 into 5 by 6?
Yes. No.
8
into 5 divided by
40 by 78.
No, it's 2. Yeah, by 78 means what? 13 into 6, right?
Yeah, 18 to 5.
So what will be the interpretation for this one? That means you are drawing, you are choosing the 8 balls, 8 balls out of 13, red balls. For finding the probability of red balls is 8 by 13.
Sir, I think I have an explanation.
Yes, please.
So I believe like the answer is 5C1 by 13C2.
Okay.
So the way I made sense is like drawing simultaneously would mean like either you can first draw red and then draw blue, or you can first draw blue and then draw red. So basically, you are doing the individual and adding these two up.
Okay.
So which
So
is
what will be this?
that would be 8 by 13 into 5 by 12, and the other is also 8 by 13 into
It
5
will
by
be two
12.
times.
Yes,
It will be
2
two times.
into
See, what is
yeah.
the question?
Yes,
You
sir.
are drawing, and it can be, we are not considering the order. Okay.
Yes.
Suppose what is the question? One of the ball is blue and one of the ball is red, right? Then it will be red ball blue or blue red, right?
Yes, sir.
Now, what is this? This is the same as 8C1 into 5C1 into 13C2.
Yes.
Right?
No, no, sir.
No, actually, it's not
I
same.
think factorial 2 will be there, right?
It will be
According
2
13
factorial is 2, right?
So
One
13
second,
feet.
We have to
one
multiply.
Sir, it's actually like first we are taking red ball.
Is it not
Then
the
we are
same?
Yes.
It is the same, right? 8C1 is 8, 5C1 is 5, 13C2
No,
is 13 into 12 divided by 2.
Yeah, so that would be 13 into 6.
I mean, 2 divided by 12 would give you the 6 again.
One second.
Okay, this is 2
What?
into, yes, it's same.
Yeah.
It's same.
What is this? This is what?
This is same. This is
This is-
same.
See, what is the meaning of 13C2? Means you are drawing, I mean, you are selecting two balls out of total 30,
Yes, right.
right? And one is the red and one is the
Blue.
blue. And here what we are doing? Okay, let it be. If it's if you feel difficulty, then this is a simple one. Means suppose condition is like one of the ball is blue and one of the ball is red. Then what will be this? It can be red blue or blue red.
Yes.
This is right or not? Right? Now, what will be this? For red blue, it will be 8 by 13 into 5 by 12, right? Or it can be it will be 5 by 13 into 8 by 12, which is the 2 times of, I mean, this is the same as this one. Suppose condition is like first ball is the red and second ball is the blue. Then what will be the answer? Only this one, right?
But in this case, this will be the answer, right, sir? Because it is saying first ball should be red.
Yes. Yes. That's why it's the condition. Suppose question is like both balls are blue and with repetition. Then what will be the answer? Anyone wants to answer this question?
5 by 13 into 5 by 13. 5 by 13 into 5 by into 4 by 12.
And why 4 by 12?
Sir, please again the question.
With repetition, sorry. 5 by 13 into 5 by 13. Sorry.
Yes. So
Sir, I have one more follow-up question, if you don't mind me. I'm very sorry for this.
Yes, please.
So there was a question in the activity questions. It was in question 8 point, I think assignment 8.2 regarding the same balls being drawn out randomly.
Okay.
8.2, I believe.
Which one?
I believe it's the second or the third one. Yep, the second one. Yep. So how
Okay.
would we do this, sir? If the
Okay.
balls.
Okay, let's do. So, what is the question? And balls in a drawer, 7 are red and 2 balls are chosen randomly. Then what if the both ball is the red, right?
Yep.
Now, n ball in total, right? That's n. And 7 are red, right?
Yes.
From this, we are drawing 2 balls, right? We are, I mean, choosing the true balls. What is the probability that both ball is red? So probability of both ball is red means first ball is red and second ball is also red.
Yes. Makes sense.
So,
Yeah, I understand now.
What
Thank
will
you.
be the okay?
Yeah, sorry,
Then
I got
what
it
will be
wrong
the
the first time I
probability
did it.
for the just tell me what is the probability for the first ball as red?
That would be 7 by n.
And what will the probability for
6 by n
second
minus
ball?
1.
6 by n minus 1, which is the same as 3 by
4. Yeah.
Or you can interpret like this. In total, you have to choose 2 balls, that is NC2.
Yeah.
And you have to select 2 red balls, that is 7C2.
Okay, sir.
Which is same as 3 by 2. If you solve this quantity, you will get this.
All right. Thank you, sir. Thank you.
Got it?
Yep, got it. Thank you.
Sir, one question just now you told, right, without repetition. So it will be like 5 by like 8 by 13 into 5 by 13 only, right?
No, 5 by 12, because without repetition you have drawn. Yes, without repetition.
No, sorry, with repetition you told, right, lastly, sir, that if it is with repetition, then it is 8 by 13 into 5 by 13, right?
Yeah, in that, see, if you if the first ball is red and second ball is blue, and we are drawing with repetition, then it will be 8 by 13 into 5 by 13.
Yeah.
I asked that question, both are blue, then it will be 5 by 13 into 5 by 13. Right?
Yeah.
So in the activity question that you discussed, so we are taking 7C2. Sir, we cannot take like 7C1 into 6C19 this question. Like first we are taking one ball out of 7, then we are taking one red ball out of 6 red balls.
See, what is this one? You have to choose 2 red balls, right?
Yes, sir.
Right now.
Yes.
So you have to choose 2 red balls, and both balls should be red, right?
Yes, sir.
And you have 7 red balls. Then in how many ways you can choose 2 red balls out of 7 balls?
7C2.
That's it.
Yes, sir. That approach is wrong. 7C1 into 6C1.
Yeah, see, if you're doing 7C1, that means what? You are choosing one ball out of 7, right?
Yes, sir.
Then again you are selecting one ball out of 6. Then what will be this denominator? What should be this denominator?
Actually, this denotes that we are not doing this activity simultaneously. We are doing it one after another.
One after the other. If you are doing 7C1 into 6C1, that means 7C1 divided by NC1 into 6C1 divided by N minus 1 C1.
CD. Okay, sir.
Got it?
Yes, sir.
Means you are choosing the first ball out of N, and first ball as a red from the 7, and first ball out of, second ball out of N minus 1, remaining N minus 1, and one ball remaining 6 ball, which is same as this one.
Okay.
Got it?
Yes, sir.
Okay, let's move for the next slide. Yeah, that was the correct answer. Okay. So yeah, in this question, be careful about the concept of independence. That is the hint from my side. Be careful in this question whether it will be independent or not or something. Be careful for the concept of independence. And the people who have not joined this peer deck till now, kindly enter on your browser joinpd.com. This one, and after that you have to enter this top right corner code HZIBS.
Sir. Hello, sir.
Yes, please. Yes, please.
Sir, if the two event is independent, like PA and PB, then PA intersection be equal to PA into PB. This is the rule. No?
This is the mathematical notation, and in layman term, what you know what is the independence concept?
No, actually, I just guess that the event is not dependent with other event.
See, yeah, independence means probability of A given B equal to probability of A, or probability of B given A equal to probability of meaning of this one is means there are suppose two events, then occurring of the happening or not happening of an another event does not affect the happening of the first event.
Sir, mutually exclusive event and independent event are same.
Okay, how you can they are same? Mutually exclusive means what? Probability of A intersection B is equal to 5.
Tossing of coins is a mutually exclusive events.
Okay.
Head and tail cannot occur simultaneously. An independent event also not dependent with other. That's why I guess.
No, you are getting you are getting confusion actually. Mutually exclusive means what? Probability of A intersection B is equal to 0.
Yes.
Okay,
yes.
means mutually exclusive means you can say disjointed. That means A intersection B is as a null event. There is no common point between these two events. That means probability of A intersection B is equal to 0. Independence means what? Probability of A intersection B equal to probability of A into probability of B. So this one is, so can you say this one is the same as this one?
Okay.
Right?
Sir, can you please give one example of independent event?
Okay, I will give the example. Let's do this.
The tossing of a coin would be an example.
I see.
Question itself has the answer.
Sorry?
Question as the example for independent event.
Can you repeat?
No, I don't want to put any spoilers. I'm just telling that this question has an example for an independent event. Let's say there are two.
Yes, you have to think whether it will be independent or not.
Hello.
Yes, Philip.
Hello. Sir, I have a doubt. If we have three events A, B, C, and all three events are independent, then condition for this is P of A multiplies P of B multiplies P of C equal to P of A intersection B intersection C.
Sorry?
Sir, for intersection of three sets, if A, B, and C are independent sets, then condition for this is P of A intersection B intersection C equal to P of B, P of A multiplies P of B multiplies P of C.
But there are three more conditions. Events should be mutually independent. Mutually independent means pairwise independence. Means probability of A intersection B should be equal to P, probability of A into probability of B. Probability of B and C should be equal to probability of B into probability of C. Probability of A intersection C should be equal to probability of A into probability of C, as well as probability of A intersection B intersection C equal to probability of A into probability of B into probability of C.
Sir,
all four conditions should be satisfied.
Sir, please explain question number 4, activity 8.6.
Okay, we will discuss, rest of the question after the end of this slides. Okay.
Sir, in this question, is the student passing the paper or passing both the sections? Passing the paper or passing the both the sections?
There is students are writing an exam with two sections. That exam consists of two sections. Okay.
Yes.
So yeah.
So it is passing the exam or passing both the sections?
That's why, please, try to understand this.
Because here it is written passing both sections.
Yes. That's why I said we focus on the what I said. Concept of independence. Okay. Whether passing the both section will be independent or not.
Hello? Yeah, it is independent.
Yes,
it is independent because let's say I'm giving two exams, English and Tamil. I might pass Tamil, clear Tamil, but I'll fail in English. So they are independent of each other.
Okay, let's see. Let's see. Okay, there are 43 responses. Let's wait for 1 more minute. After that, we will move.
So about that, in generally in a test, there must be a condition, right? That, a student must pass in all the sections to pass. So that must be a dependency, right? Like for English also you should pass, or Tamil also you should pass.
Yeah, the condition should be there. I mean, should be clearly mentioned, and in independence things should be clear mentioned whether it's independent or not. If it's not obvious thing, then it should be mentioned whether it will be independent or. Okay, we'll see the solve.
But to clear English, it is not dependent on Tamil. To clear
See,
Tamil, it is not dependent.
no, actually, Siva, you are taking a particular example.
Okay, I'm sorry.
Okay. Yeah. No, it's okay. See, sharing the concept and your points, it's good thing actually. Okay, so I think we can move. Let me see the responses first from your sides. 44 people saying 0.72 and only one people is saying none of the above. Okay, who has entered none of the above one? Who has entered none of the above? See, feel free to tell us. Hello, am I audible?
Yes, sir.
Yes, sir.
You are.
Who has entered the none of the above? That is the correct answer. That's why I'm asking.
So I have.
Can you speak again? Hello. Hello. Can you speak again? Okay. See, in this question, see, probability of there is given only two things. Probability of passing section 1 is 0.8, passing the section 2 is 0.9, right? And in the question, it was given that section 1 probability of, we have to find the probability of student passes the both section, right? Then see here independents are, I mean, see, we do not have given the, I mean, independence is not here. See, in this question, actually problem is not fully specified what are given and what are not given. Okay. And all of you have just multiplied 0.8 into 0.9. If 0.8 into 0.9 should be
Why
there.
second event section 2 given that section 1? You said that all the section you have to pass. Then
okay.
Can you explain the second probability, section 2 pass, given that section 1 pass?
This is the given or not? I'm asking.
If I just organize it like section 1 pass and probability of section 2 pass, then is it wrong?
Yes,
because passing in section 2 is not dependent on section 1, sir. One can pass in section 1, but he may fail in section 2. So
see,
it is.
That's why I said, see, here it might depend. It's not an obvious thing like passing the section 1 is not independent. Sorry, is independent from the passing the section. Passing the
in this
section.
case, we are taking the
right?
possibility that there must be some relation between those sections, like that.
Yes. See, here it's just given that probability of passing section 1 and probability of passing section 2, right? I'm not saying probability these two passing in these two sections are independent, right? Your exam is consisting of these two things, right? It might depend or not. Just tell me.
Sir, then I may write
Yes, sir, it might
section 2
depend because
pass,
we are talking
then
about same subject
section
but different
1 pass
sections.
given that section 2. I may write it.
Can you repeat?
Probability of section 2 pass into probability of section 1 pass given that section 2 pass. I may write it. All are same.
It can be written the other way also, right? Probability of
This you can write is you can write is like this one. Also, yeah, you can write like this one. But here things are bent and problem is not fully satisfied. We do not have this quantity. Okay, we have just passing section 2, not given like a section 1 pass. If you pass the section 1, then what will be the probability of passing the section 2?
So if in question,
all of you getting my point or not?
so if in question,
Yes.
if it was mentioned that it is an independent event, then the answer will be 0.72.
Yes.
If it is mentioned, then only.
See, in independence
Yes,
question,
yes.
if you things
Sir,
are not
here
given
it
like
is not
things
mentioned that it is independent. Then here it is also
Yeah.
not mentioned that it is dependent. So how do we know which is
No
correct?
question will mention it is independent or dependent. You have to obtain whether it is independent or not. It will be not mentioned.
No, for
So how
independent.
can we
But it is
specify in
regarding
this
to the
case?
exam criteria. If it allows like section 1 pass, then section 2 has to be passed. Otherwise, section 1 is mandatory or not.
Your voice
Sir,
is
your voice
choppy.
is breaking. Your voice is breaking. We cannot hear you, sir.
Hello.
Yes, sir.
Yeah, sorry, I got this. Yeah, you all of you are agree with this thing or not?
Sir, what is the answer?
Yes, sir. Yes, understood.
Okay. See, in independence question, if things are obvious, okay, then it's okay. Otherwise, it will be mentioned like these two things are independent of each other, right? So see, here you are given the probability of passing the section 1, which is 0.8, passing the section 2 separately 0.9. But if you find the probability of section passing the section 1 and section 2, then you have this quantity, but this not I mean the second quantity you do not have. You can do the vice versa, means probability of section 2 pass into probability of section 1 pass given of probability of section 2 pass. Then again in that case situation, this quantity it's not given. I mean, we do not have this probability in the question.
So can't we take it as both of them are independent events, as because both passing the section 1 and passing in section 2 cannot be related to each other?
No, see.
Sir, can you
it might
correct
be
this? Can you correct this question and then solve, sir? Or like what you?
Yeah. See that's there. This is the prelude of question 2. Correct one is the next in the next question. Okay. So first of all, tell me this. You got this concept? Why this? I mean, why the problem is not fully satisfied? Specified. Now I hope you have clear. I mean all the things are given in the question. Now after now calculating this question relate to the previous one. What are relation? I mean to the previous prelude to this question.
Sir?
Yes, please.
Sir, probability of section 1 given that section 2 equal to section 1, we take it.
That is the concept of independence. Means probability of A given B equal to probability of A. Means happening or non-happening of B does not affect the happening of A.
Hello, sir.
Yeah, yes, please.
Sir, after this session, will you take one question from activity 8.2?
Yeah.
I got
We
the
will
answer,
discuss.
but I just want to check the approach is correct or not.
Yeah. We will discuss. We will discuss. No worry about it. Okay.
Okay, thank you, sir.
Yeah. Okay, there are 42 responses out of 56. Let's wait for a couple of seconds. After that, we will see. I think this is too much.
So,
Can we
Yes.
move ahead, please?
Yeah.
We
Let's
have
see the
math session
responses.
also.
Okay, 0.2, 0.72. Okay. All of you have answered 0.2. Yeah, that is the. Yeah, 1 second. Screen is blank, right? Yeah, now. Yeah. See here. In this, events are independent, right? It was mentioned.
Right, sir.
Right. So probability of, independence means what? Probability of A intersection B equal to probability of A into probability of B.
Yes.
Right. So probability of passing section 1 is given to which is 0.8 and probability of passing section 2 is 0.9.
Right, sir.
So, and in the question it was mentioned these two events are independent. So probability of passing section 1 and passing section 2 is equal to passing section 1 and passing section 2, which will be 0.8 into 0.9, which is nothing but 0.72.
72.
Is it okay?
Yes, sir. Yes, sir.
Yes,
Yes.
sir.
It's clear. It's clear for everyone.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Let's move for the next slide. Yeah, this is the prelude one for the third question. So I think 5 to 6 minutes will be more than enough for this. Yeah, please proceed. Okay, there are 33 responses. Let's wait for 1 more minute. After that, we will proceed. Okay. Okay, so let me see responses from your side first. 0.899, 0.89. Okay, 0.8, 0.89. Okay, majority is 0.89. Someone has entered 0.901 as well. Okay, so to like to tell how did you approach this one? I mean, which method is applied here?
Sir, I have applied tree method.
Okay. Anyone else?
The law of total probability.
Okay. Yeah. That is the right. Okay, see, in question, you can define the events like selected person is a male, selected person is female, and L as a selected person is left-handed. Okay. In the question, if you see, it is given that 45% are female and 55% are male. Okay. That means probability of M is what 0.55, right? And probability of F is 0.45. And in the question, among all the females, 9% are left-handed. That means probability of left-handed given that female is what? 0.9%, right?
Right, sir.
And probability of, and what is among all the males, 11% are left-handed. That means probability of being left-handed given male is 0.1, and probability of male is given to you, probability of female is given to you. In the question, it has been asked, what is the probability that person is not left-handed, right? Then I can do like person is not left-handed, then I can do 1 minus probability that person is left-handed. Can I do or not?
Yes, sir.
You know, probability
Yes,
of A
sir.
complement is what? 1 minus probability of A. Now, we can proceed like person is left-handed. That means probability of L. So, probability of L, how we can find? Probability of L means what? Person, probability that male and he is left-handed, or probability that female and she is left-handed, right? Everyone is getting this one or not? Hello?
Right.
You know,
Yes, sir.
see,
Yes, sir.
yeah, we have to find the person is left-handed. Then person can be male or female, right? Now, probability of M and L means what? Probability of M intersection L. I can write this as probability of M into probability of L given F, right? Plus probability of F and L, I can write probability of F into probability of L given F, right? Now, this probability of M is given to you, probability of L given M is given to you, plus probability of F is given to you into probability of L given F is given to you. Just multiply this and calculate the, you will get the 0.101 for what? Probability of person being left left-handed, and we have to find probability of person is not left-handed. So we have to do 1 minus 0.101. Another approach can be like this one. You know the probability of being left-handed or male is what? 0.11 1, right? So probability of probability of not left-handed given male what? How?
Sir, I have
It will be
subtracted it from
1 minus 0.11.
it will be 1 minus 0.11, right? So you can directly compute from here, or you can compute for the left-handed and minus this quantity, right? Is it okay for everyone?
Right, sir. Okay, we can move.
Okay, let's move for the next slide.
Sir, I did it through that contingency table, but my answer got like 8.80, like not 0.899.
Okay, table means male, female, and not dependent, right?
no, sir.
Yeah.
Your voice is choppy, sir. Maybe internet connection issue today.
Yeah, I think now it's okay.
Hello, sir.
Yeah, yes, please.
Sir, males are 0.55 and left-handed males are 0.11. So I directly subtracted 0.11 from 0.55. Is it possible for right-handed male?
What did you do?
From 0.55, I subtracted 0.11 to get right-handed male, because only number of males are 0.55 and left-handed also given.
Okay.
And then
And
the same thing I have done for female too, and then I added both the answers.
okay, so is there any okay, see, you are subtracting the probabilities, not numbers. Okay, see, you can approach it like, see, out of, let's say 100 are okay, 100 are 100 is the population, then 55, right? Out of these 55, 11% of the people are left-handed.
Sir, there is some network issue. Your voice is not
Your
clear.
voice is breaking.
Sir, too much choppy, sir.
Yeah. Now is it okay?
No, sir.
No, sir. Still.
I think there might be some network issue. Now, am I audible?
Yes, sir. Better from last.
Okay. See, from here you can find also like number of person and proceed further. I think minus is I don't think is the correct one, because
Sir, will you show the question once again?
this one.
Not question.
This is the question. Hello.
Cause sir, I also got the answer 0.8. That's why I was asking.
Okay. Okay. Komal, we can discuss after the, I mean, end of the slides. Okay.
Yes,
Your
yes.
approach, we will your and Ketan, two people we discuss. Also, this one the previous values you have to use in this question. So just do this and try. I think 5 to 6 minutes will be more than enough for this question.
पूरा क्वेश्चन सॉल्व हो गया।
Hello.
Yeah, yes, please.
Yes, sir. My name is Prashant, sir. And what happened is that I haven't received my PMQ marks of week 6 yet, sir.
This is graded, right?
Yeah, yes, sir. The part 2 of
Okay.
graded assignment.
Okay, we'll check. We'll check that. There are 18 responses. Let's wait for a couple of minutes. After that, we'll proceed. Any one of you are trying, or should we proceed? Because
sir.
there are.
Sir, please proceed.
Proceed, sir.
Okay, let's proceed. Okay, let's see the responses first from your side. 0.59, 0.59, 0.11, 0.0673. Yeah, 0.13 as well, 0.55. Okay. Yeah. Okay, see. Which method is applied here?
Bayes rule.
Bayes theorem.
Yeah, that's it. Simple.
Yeah, I tried
Because
that one.
hello.
I tried that only. So it's like probability of male given lefty is probability of left given male into probability of male divided by probability of this one, right?
My slide is visible or
So what is the correct answer?
correct answer is 0.599. Okay. See, in this one, in the previous one, you see what is the question? Question is to find the probability of male when that the person is left-handed, right? Right or not? Right. So I can write probability of male given that person left-handed. So I can write probability of male and person left-handed divided by probability of left-handed, right? Now this quantity I can write probability of male into probability of left-handed given male divided by probability of left-handed. Okay. In the previous question, by the total probability rule, you calculated the probability of L, right? Here you have to just compute the probability of M times probability of L given M. Is it okay? And which is probability of M is 0.55 and probability of L given M is 0.011. Is it clear for everyone?
Yes, sir.
Yes. Okay. So let's proceed for the next question. Yeah, this is the last question is there. Yeah, I think it will take 7 minutes. Okay, please do it. Okay.
Sir? Hello?
Yes, please.
Still how many question is there, sir?
This is the last one. This is the last one.
Oh, okay, sir.
We will wait. Yeah, 2 more minutes. After that, we will proceed the solution.
Your laptop battery is running out, sir.
Sir, hello, sir.
Yeah, yes, please.
Sir, in the portal, week 5, week 6, and week 7 marks is not updated yet.
Yeah, it will be updated. No worry about it. In due time, it will be updated. Okay.
Sir, can we discuss it? We have math session from 8 to.
Okay. Let me see the responses first. Okay, 0.57, 0.4. Oh, someone has entered 4. I don't know. 4 cannot be because probability cannot exceed 1. 0.6 is 0.1. Okay, there is some variety. And this is the little bit long question actually. Okay, so let's move. Yeah, steps 1, we have to incorporate all the possibilities. Sorry, 1 second. Let me connect my top charger. Yes. So in the question, what is the meaning? How you can do? I mean, you can calculate the probability of pass. That means he can pass. There is a condition like a student appears for aptitude test, okay, and student pass the aptitude test if he passes in either section 1 and 2 or section 1 and 3, and probability of student passing, I mean, individual things are given. Okay, so how we can do? Pass means what? Section 1, pass in section 1 and pass in section 2, or pass in section 1 and pass in section 3. This is the given, right? In the question already, right? Pass means we can I mean, in short, we can write it like, okay, this things is clear. It is given already in the question, right? Now,
Right, sir.
yeah, now probability of pass. Probability of pass means what? Probability of pass is what? If you see, let's denote pass 1 as P1 and pass 2 as P2, right? Now, in the question, it is given that probability of pass, okay, student will pass when in section 1, right? Okay, let's say S1 and S2 in section 1 and section 2, or it was section 1 and section 3, right?
Yes, sir.
Okay, these things are in the given. Let's denote it as A, denote it as B, right? No, it's not a probability. Oh, sorry. Sorry about that. Pass means what? If you see in the previous one, pass 1 and pass 2. Say section 1 and section 2, or it was section 1 and section 3, right? So this is A, this is B. If you see, right? This is A, this is B, or you can do, right? Now, then probability of pass. Probability of pass means probability of this A or B, right? Are you getting?
Yes, sir.
Probability of pass means what? Probability of this section 1 and section 2 or section 1 and section 3. That means A or B, right? Can I write this one? A or B means A union B. A plus B minus intersection B.
Can't understand, sir. So much of it.
Okay. Let's do pass 1 and pass 2 as A and pass 1 and pass 3 as B. Can I do?
Yes, sir.
Right? So what is this? What is the pass? Pass, right?
We can't hear you, sir.
Pass
Sorry.
is what? Sorry?
We can't hear you, sir. So much choppiness.
Okay, now it's okay or not?
Yes, a little bit better.
Okay. Now, you know, see, pass is what? Pass 1 and pass 2 or pass 1 and pass 3, right? This is the A, this is the B, right?
Yes, sir.
Now, probability of pass, can I write probability of A union B? Can I write or not?
Yes,
These things
it's A
is
or
given
B, so we can write A union B.
A union B. So I can write probability of A union B as probability of A plus probability of B minus probability of A intersection
A
B,
intersection
right?
B, right.
Is it clear? Now, A is what? Pass 1 and pass 2. B is what? Pass 1 and pass 3, right? If you see,
yes, sir.
This is your A, this is your B, this is A and B, right? And in the question, it's given that all are independent, right? Now,
Right.
if all are independent, then pass 1 and pass 2 and pass 1 and pass 3 are independent. Then can I write probability of pass 1 and pass 2? This is A and this is your B equal to, sorry, probability of pass 1 and pass 2 and pass 3 equal to pass 1 and pass 2 and pass, I mean, these two are same. So all independent I can multiply it by P into P is what? P is given for P in the question, right?
Right, sir.
So P into 1 by 4 into 1 by 3, which is equal to P by 12, right or not?
Yes, sir.
Because see, why I multiplied? Because in the question, it was
It is
already
saying
given
and.
that, and these are independent events. It's already given, right?
Yes, sir.
Everyone is getting or not?
Yes, sir.
Hello, hola. Okay, is it clear for everyone?
Yes, sir.
Now, probability of pass and pass 2 will be what? Probability of pass 1 is P and pass 2 is given to you in the question is 1 by 4, right? So it will be P into 1 by 4, that will be P by 4, right?
Right, sir.
And probability of pass 1 and pass 3 will be what? Pass 1 probability is P into pass probability of pass 3 is 1 by 3. So it will be P into 1 by 3, which will be P by 3.
Yes, sir.
Right? Now, so probability of pass, just put the values in the previous one. It will be P by 4 plus P by 3 minus P by 12, which will be P by 2. Now, you know, finally we get P equal to 2 by 3, which is 0.67. How we get? Because in the question it is given that passing is the, I mean, passing in the aptitude test is 1 by 3. So probability of
Excuse me,
passing
sir.
is P by 2. Yes.
Sir, in the last step, so P of pass is equal to P
Huh?
by 4 plus P by 3 minus P by 2, 12. One basic doubt is here when the question is stating it is independent. So why are we subtracting the intersection part?
See, we are putting the values in this equation, first one.
Okay, so for that instance, it is we can apply the independence rule.
Yeah, independence means, see, probability of pass one and pass two. See,
will
yeah.
be the product.
Yeah, these things are independent. If you interpret it as A, can I write probability of pass as A union B, that means PA plus PB minus PA intersection B, right? Now we have to calculate probability of A, means probability of pass one and pass two, right? So these are independent. That means probability of pass
so for
one
that instance, we
into
can multiply
probability.
directly.
Yes.
Got it, sir.
So after computing the all the probability, this one and this one and this one, we have to put the values in this. That was P by 4 plus P by 3 minus P by 12. So we got the probability for pass as P by 2. Now, this P by 2 in the question, it is given that probability of passing the aptitude is 1 by 3. So P by 2 is 1 by 3. So P will be 2 by 3, which is nothing but the 0.67. Is it clear for everyone?
Yes, sir.
Hello, these things are clear to everyone?
Hello, sir.
Yes, please.
I had a different approach. I took three situations. One in which a person has passed in pass one and has passed in 1 and 2 and has failed in 3. Then second situation where he has passed in 1 and 3 but failed in 2. And the third in which he has passed in all the 3. So I added all these 3 conditions. I took the probabilities of all these 3 conditions and added them. I got P by 2 only. And I equated this P by 2 to 1 by 3 and I got this 0.67 only. But my approach was where I took 3 conditions. One in which he has passed in 1 and 2 and failed in 3. One in which he had passed in 1 and 3 but failed in 2. And one in which he had passed in all 3. And then I equated it to 1 by 3. I got the same answer, sir.
Okay, and pass in 1 and 2 and failed in 3, right?
Yes, that is the first condition. Passed in 1 and 3 and failed in 2. That is the second condition. And third in which he passed in all 3. That is the third condition.
Suppose this is complement and pass in 3. Okay. And what was the third one?
He passed in all 3. Passed in all 3.
Okay. Okay. So you did like probability of pass one, that means it will be P by
4 into 2 by 3. P by 4 into 2 by 3. That was first. Second is P by 3 into 3 by 4.
One second. It will be P into 1 by 4 into
2P by 12. You can say 2P by 12.
Yeah. You did 1 minus 1 by 3, right? Plus you did for this one P by 4. No, it will be P by and 1 minus 1 by 4. That means 3 by 4. Yeah, 3 to P by 4, and it will be 1 by 3, right?
Yes.
Again, it will be P into.
Sir, 3P by. Okay, right, sir, right. And third condition was P by 12.
It's P by 12. So it will be
6 P by 12. 6P by 12, which is 1 by P by 2. One is
P by 6. That is P by 4 plus P by 12, right? Hello.
Yes, sir. 2P by 12 plus 3P by 12 plus P by 12. So total is
that's.
This is also equal to P by 2, sir.
Actually, it's reconnecting. I'm unable to write here. Okay, I think
So instead of
Yeah. Please proceed. Go ahead.
2p by 12. One is 2p by 12. Second is 3p by 12, and the third is p by 12. So total is 6p by 12, which is p by 2, and
that is p. It will be p by 2, and you equate it as 1 by
1 by
3,
3.
right?
So I got 2 by 3.
Yeah, that one is also correct. What is wrong?
So that approach is correct, no, sir? Because all three are independent, so I can multiply the probabilities of all three to get the what do you say?
All three are independent, and for passing criteria, you have to pass P1 and P2, and you have to pass P1 and P3.
So all three are independent, so I can multiply their probabilities, no, sir, to get the intersection.
Yes.
I can do that, no, sir?
Yes. Okay. Okay.
Hello, sir.
Yes.
Sir, here for calculating probability of pass 1 and pass 2, multiplication rule is not used, which was taught in lecture 3, 8.3 lesson.
Okay, see, these are, 1 second, Ketan is here or not? Ketan? I think Ketan is not here, but we had to discuss. Yes, please tell me.
So the multiplication rule, which ma'am taught in lecture 3rd, for probability of pass 1 and pass 2, we are not using.
See, when we have to multiply, see, if you are saying multiplication, means you are saying probability of pass 1 and pass 2 equal to probability of pass 2 into probability of pass 1 given pass 2, right?
Yes, sir.
Okay.
Your voice is breaking.
Yeah, there is some network issue from my side actually. 1 second. Yeah, see, in the question, if you see, it is given all these events are independent, right? That means if you do probability of pass 1 intersection pass 2 equal to probability of pass 1 into probability of, I can write now. Yeah, you are saying like this one, right? Pass 1 and pass 2 equal to probability of pass 1 into probability of pass 2 given pass 1, right? You are saying this one, right? Now, in the question, it is given that all the events are independent. Means these things, probability of pass 2 given pass 1 is equal to probability of pass 2, right? Independence means what? Probability of A given B is nothing but the should be equal to of A. That means happening or non-happening of B doesn't not affect at the A, right? So here happening, I mean passing in 1 and 2, passing in or failing in 1 doesn't not affect for the pass 2. That's why it is given that all the events are independent. If there is some condition, there is some dependency, then we have to apply this one.
Okay, understood.
Right? And same things we have to think in this question, this conditional probability, this section 1, because if you see in the question, we have to just given the probability of pass in section 1 and pass in section 2, right? There is not given any like dependency, whether section 1 is dependent on section 2 or section 2 is dependent on section 1, or like after qualifying the section 1, we have to probability of passing the section 2 is something or not, or I mean there is not given like independency for the section 1 and section 2. So that's why in this question we have I mean problem is not fully specified.
Okay,
So
sir.
you got,
that means whenever independent event is mentioned in question.
It will be there.
Okay, sir.
Okay, so this one is clear, or I mean, this question is clear for everyone or not who are in the session?
Yes, sir. Sir, I had a doubt, sir,
Hmm?
in this question only. So in like in next part of this question, it was mentioned that it is an independent event.
Yeah.
Like passing section in one and
Hmm.
section 2 is independent event. Sir,
Independent,
but
yes.
yes, sir. Sir, using this information, can we conclude that, sir, failing or not passing in section 1 and not passing in section 2 is also independent? We cannot say, na, sir. That's my question.
See, yeah, here you cannot say anything about this.
Yes, sir.
Because see, what is the question? Question is just you are given probability of passing section 2 and probability of passing section 1, right? There is,
yes, sir.
I mean, there is not anything about the dependency of section 1 and section 2, right? Question is like, suppose question is like, probability of passing the section 1 is 0.8, probability of passing the section 2 is 0.9, and probability of passing the section 2 given section 1 is 0.6 and something whatever, right? Then what will the probability of passing section 1 and section 2, right? Then I can
Yes, sir.
compute the probability because some dependency is given. Some dependency
Yes,
is
sir.
given, like it can be, this quantity can be given, or there should be mentioned like passing the section 1 and section 2 are independent, right? Then we have to just
Yes.
multiply it,
Sir,
right?
sir, like here, if section 2 conditioned at section 1 is 0.9, then we can say that it is an independent event, na? Like
Yes, yes,
what you
yes.
write on
If
Jamboard.
see, suppose in the question it is mentioned, forget about it is mentioned
Yes.
that these two sections are independent, right?
Yes,
Passing
sir.
in these two sections are independent. Then can I write this probability of section 1 into probability of section 2? Let's write given section 1. Okay. If
Yes,
these
sir.
are independent, so I can write this quantity as probability of section 2
Section 2 only, yes.
because probability of A given B is equal to probability of A when A and B are independent.
Yes, sir.
Means happening or non-happening of B does not affect the happening of A, right?
Yes, sir.
So if these are independent, then it will be probability of S1 into probability of
Yes,
S2,
sir.
that nothing but
Sir,
0.8
this I
into
understood,
0.9.
sir.
That, right?
Sir, in continuation to the question, like here it is mentioned that section passing Jamboard only, sir.
Yes.
So can you show the Jamboard? So here,
Yes, sir.
like in question, it is mentioned that it is both the events are independent. So using this information, so can we conclude that not passing in section 1 and not passing in section 2 are both independent
Independent.
events? Can we conclude,
Yes,
sir?
you can do.
So it will be always true, sir.
Yeah, because see, there was just some question in the activity. No, not in the activity. It was in graded. I will show you. The log of that.
So like question number.
If you see this last question, right?
Yes, sir.
It's about division. Suppose your A and B are independent, right?
Yes, sir.
That means probability of A intersection B equal to probability of A into probability of B, right?
Yes, sir.
Now I have to do probability complement B complement.
So 1 minus.
Can I write this as probability of A union B whole complement?
Yes, sir.
You can write it, right? Now I can write it 1 minus probability of A union B.
Yes, sir.
This now I can write 1 minus PA plus PB minus probability of A and B, right?
Yes, sir.
Now, so see, the question is given these are independent. That means 1 minus PA minus PB plus I can write this quantity as PA into PB.
Yes, sir.
Now, can I write this quantity 1 minus PA I can take probability of B as a common, so I can write is 1 minus PA again here for these two.
Yes, taking okay, yes, sir.
Now
PB
taking
common,
probability
yes, sir.
B as common, I can write
Yes,
1
sir.
minus probability of A, right? Now,
Yes, sir.
if you compare from here, one second, let me erase these things. Now, so can I write 1 minus PA as a probability of A complement minus probability of B into probability of A complement,
A
right?
complement. Yes, sir.
Now, if you take probability of A complement as a common, it will be 1 minus probability of B. This is
Yes,
the
sir.
into. Again, I can write probability of A complement into probability of B complement. That means
Yes,
what? If your A and B are independent, right, then A complement and B complement is also independent. That means, I mean, passing in the section 1 and section 2 are independent, then failing in section 1 and section 2 are also independent.
So, sir, then I have a question like a graded assignment of this week. So I don't want the answers. I just wanted to confirm, sir. Like one
Which
question
one?
of graded assignment. Sir, question number 2.
Okay.
Sir, in this question number 2, it is given independent event. Sir, but like for correct, like if A probability of A getting a correct answer and probability of B predicting a correct answer is given, and both are independent event. Now they have given that probability that A is also wrong and B is also wrong. That is like P of A complement intersection B complement is 1/237.
Okay.
So then we have to find the probability that both the answer is correct. That is P.
Okay.
So sir, here we have to find A intersection, like probability of A intersection B, or we have to find A union B. That's my like I didn't understood.
Sir, I think there is some.
Given that
the same system, so it can be wrong as well as it can be.
Sir, your voice is breaking. Sir.
Yes, sir. I'm not able to hear you, sir.
Sir, your voice is breaking.
Now is it okay?
Yes, sir.
See, here the probability that their answer is correct, and for wrong it is given.
Sir, still your voice is not clear, sir.
Sir, for a second it becomes clear, then it starts to break, sir. Sir, not audible, sir.
Hello.
Yes, sir. Hello, sir.
Hello. Am I audible?
Yeah, yes, and now you are like seems audible, sir.
Okay. Just try to actually some network is on.
Yes, sir.
Sir, there is some network. Still your voice is breaking, sir.
Yeah. See, there is some network issue. Okay, Saad has raised hand. If my voice is clear, then we can discuss. Otherwise, we can do the session.
Hello, sir.
Hello.
Yes, on I have a small doubt. You can say the conceptual doubt or something. I'm not able to understand I can understand some all mathematical concepts that we have learned in week 8 regarding the independent events, disjoint events, and what everything is mentioned in the videos, as well as you have also taught it in the last session. But
Okay.
in some questions I can't apply it directly mathematically. So since I am not from mathematical background, I have approached many questions with the tree method, which is not just a visual representation of mathematical approach. Am I right, sir?
Yes.
So, sir, for some questions, for example, that cricket and football problem in activities questions. So in that questions, yeah, that's the probability when it is not equal to one, like the two probability which are provided in the questions, which is not equal to one. It means that they have some sort of intersection between them, right? That's why they are not
Yes.
summing equal to one. So that
Some
point,
matching.
yeah, that point I got it, sir. But that questions I cannot solve with the tree method. So there are not more than 10 participants, I guess. So if you are comfortable, sir, can you explain that problem with the tree method? I'm comfortable just to solve it. It's just a personal preference. If you are comfortable, sir. Otherwise, I'm okay.
Uh,
Yes, so there is some network issue. Yeah, the voice is not audible.
Hello.
Yes, sir.
Yeah, I think there's some network issue. We can discuss in the next session, right? Just remind me about that one, okay?
Okay, sir. I
Because
will
I'm
remind you
getting
at the end of next session,
yeah,
probably.
actually, I'm getting disconnection again and again.
No issues, sir. No issues.
Okay, we'll discuss. Yeah, okay.
Sure, sir.
Just
Sure.
remind me that one. Okay.
Yes.
Okay, sir.
Okay,
Thank you,
sir.
sir.
Okay.
Thank you.
Yeah,
Thanks
thank
a
you,
lot,
everyone.
sir.
Yeah, thank you. Bye, bye, everyone.
Thanks, sir.
Thank you. Thank you.
Sir,
Yeah, yes, please.
sir, I have dot in graded assignments, sir, in few questions. Miss, I am unable to understand the questions, sir. So, and
Week 8.
tomorrow, yes, sir, week 8. And tomorrow is the last date to submit the
Okay.
assignments.
Okay. Just tell me fast. Actually, I have informed the support team for closing the session. Okay. Just tell me which one.
Sir, in question number 1, sir.
Okay. What is yeah. See, just think. 5-wicket haul.
5-wicket haul, yes, sir.
Yeah. Okay. Now, so just think. Out of I think you had some different data. So just think. Jahir Khan has taken the 4 or 5 wickets haul in the last 17 matches. So just think. What suppose in my question it is given that 10th one is the last 5 wicket. Okay, if 10th one is the last 5 one, then you have to choose the suppose in total he took the 4, then you have to choose the wicket haul out of what, out of the remaining, right?
Sir, here in question it is written that his match records are selected at random one by one. And before that,
Yes.
it is written that Jahir Khan has taken 6 5 wickets for in last 17 matches. Sir, the match records which is selected randomly, that is from that last 17 matches, na?
Yes, last 17 matches.
So
That's the
from
data of last 17 matches.
from last 17 matches, they have selected randomly. Okay.
Yes.
And sir, in next line it is written, if none of the match records is analyzed more than once. So my first problem is in this line, sir. What is the meaning that analyzed more than once?
More than once, see the data. See, suppose out of 17 matches, suppose he took the 5 wicket haul. That means this is the observation at the first time. It doesn't not make like the 17th matches analyzed again and he took 5 wicket haul again. Kind of miss. Suppose I